Okay, Twitch is up.
All right, maybe Riverside's
the new
just being
one
slow.
from.
Yeah, Mirella sent it to me this morning.
Okay,
right,
now we're live on YouTube.
Yeah.
Excellent. Excellent. Let
Angus left.
me pop out all the chats.
24-hour cluster stream or die.
Today's the day, folks. 24-hour stream. You heard it here first.
Yeah. I mean,
No, we keep joking about it, but it's gonna happen.
eventually. We will
Maybe, but not today. Okay. I'm set up.
Nice.
I should be too.
Let me stand in a better spot. Hello, everyone. Hello, Internet. Hello, Effect enjoyers. How are all of you this wonderful day? We've got both Mike and Mattia here today. And so I think Mike is going to maybe teach us a little bit about STM in general, but also what's changed in version 4. If you've watched any of our VODs in the past, you'll know Mike's taught me about STM once before, but I've forgotten everything he's taught me. So now we're going to do it again. But yeah, if you folks have
to reteach the same stuff all over again.
Shouldn't be anything new there. But if you folks have any questions about STM in general, this would be a good time to ask while Mike is here. So yeah, maybe we can see if anybody else has questions before we get started. But otherwise, Mike, I think you can feel free to start getting prepped.
Yeah, okay. Let me try the screen share. I'm trying 2 screens to share screen, window, entire screen, screen 1. Let's see if I'm able to screen share without leaking any confidential. Well, I mean, leaking the API keys would be the not the worst, given at maximum they're gonna consume my pro plan.
Your quota. Yeah.
My quota. there might be things that are more risky to leak. Anyway, I have prepared absolutely nothing about STM, so that's probably a good start. I would begin by describing the concept in general and kind of see where it leads by trying to architect some examples. I do hear myself, so somebody has an echo. I'm not sure who.
I blame Mattia.
Maybe we should fix that before.
I can try and mute myself.
Try. Okay, it seems it was Mattia indeed. Okay, so STM. How would I go about describing what STM is? First of all, STM stands for Software Transactional Memory, which per se doesn't really convey what it is about. I feel like the easiest way to grasp the underlying idea is by sort of making a parallelism with database transactions. What the basic concept of database transactions is that you have multiple changes and you want all or nothing to be committed. So like in an SQL database, you say begin, then you do 2 or 3 row updates, then you might run a condition, and based on the check in the condition, you decide to either commit or roll back. For example, if we have any error that we didn't expect, we roll back, and all the changes do not appear for consumers of the same database. The concept is very similar to what STM is within the boundaries of a single running program, process, or whatever. The concept of STM comes from functional languages such as Haskell and similar, but really you don't quite need to know any of the history to understand what STM is about. And maybe let's just show briefly the underlying implementation, because it's actually quite easy in TypeScript, because we don't, like in other languages where you have true parallelism, the implementation is a bit more complex. But in TypeScript, thanks to the designers, we have a single thread, and that makes life substantially easier. So I'm here in the code base of 4.0 small, and in 3.0 we had a module which was called STM. Now STM is no longer a separated module, but I've implemented it in effect itself. So when inside effect you have a function called transaction, and you can see that from the type signature of effect.transaction, we are basically running an effect and removing from the environment a service which is called effect.transaction. Now there's a different function which is called transaction with, that gives you access to a state parameter. Let's see if yes, Mattia, the autocompletion works. That's good. The idea now is that we want to see what's inside this state. Inside this state, you see that there's two things. There's a retry flag, and there's a journal. What is the journal? The journal is implemented as a map from this thing called transactional reference to a value which is a version and the underlying value. So basically, inside, let's say that, let's import transactional ref to begin with. Let's say that here I say ref equal yield dxref.make 0. This is a value of type transactional reference. The journal can be used to get the value of a ref. This will give you the value, and it will give you the version if it exists. So if it is journaled. This to say that basically the whole logic around transactional references, which is the underlying implementation of STM, is the idea of providing a journal that keeps tracks of changes before a transaction is actually committed. And when the transaction is actually committed, we end up taking the updated values from the journal and writing them to the actual references. So you can think of it like we have a journal, all the state is isolated in transactional references that are like atoms of values, atoms of data, and in one shot, we commit the full transaction. So anything we do within the body of the transaction is not observable from the outside. This is one key element. The second key element of STM is that it implements optimistic transactions. What are optimistic transactions? It means it tries to run the full thing, it tries to commit. If it fails for any reason, it keeps retrying. Now, the retry logic is much smarter than just a while loop. Basically, the retry logic means checking for all of the values that have been read during the transaction. And once any of the value changes, then we retry, which means we're not like wasting CPU on keeping retrying the same transaction all over again. We only retry when any state that we've read during the transaction have changed. Because one
Mike,
of
there
the
was
principles. Yeah, go
a
on.
quick request from the community if you could zoom in on your editor.
Yeah, I can try, but then nobody reads anything. Maybe this is.
Maybe if you can do one more tick and collapse the files view a little bit more, I think that'll help folks.
I'm also trying to remove. I'm not sure if we're gonna use open code for now or not. I've removed it for now. Let's take a little bit more now. Now it should be good.
Thank you, Mike.
You are welcome. So basically, we're describing sort of the retry logic of STM and how we only retry asynchronously if stuff changes, because it's implied that transactions are deterministic, and it's implied that they're only dependent on state, on transactional state that we read during the transaction, which means if nothing in the state changes, then the result of the transaction would be the same. And there's no point retrying if nothing has changed. I can show briefly the implementation because it's actually quite easy, or at least it felt easier than what we have in V3. And you can see that inside the transaction with function, which is the boundary of when we run a transaction, the first thing we do is we create a new state, a new journal, basically. And okay, we take the Fiber scheduler, which is probably a lower level thing, which is not so interesting. We run within a non-interruptible thing. Okay, this code was heavily changed by Tim. I can recognize the style.
Recognize the signs of Tim.
I recognize the signs of Tim. It was much easier when I implemented it. Now it's probably much more performant, but a bit less obvious. So we retry. So we run a while loop until we have a result. In the body, we restore interruptibility around the function. This is kind of very low level, doesn't really matter, but you see that we provide the state as a normal service. Recall that we created the state here. The map is mutable, the retry field is mutable, the state is very low level. You probably never have to interact with the state as a user. This is kind of a low level constructor. Then we say we tap the cause, and if we should not retry, then we simply return void. If we should retry, then we await for pending transactions. Okay, no, this gets way too complicated. Unfortunately, that's not.
Maybe it
It
also
used
be
to be
good.
easier.
Tim,
Tim.
maybe it would also be worthwhile to motivate STM a little bit too, like because I'm sure the audience like is very interested in like understanding STM, but I think even for me sometimes the like utility of STM in a runtime like JavaScript, like you start to think about like, okay, well, why do we even need something like software transactional memory in JavaScript? So maybe motivating STM
I
could
wanted
be
to
interesting.
get there because my hope is that the implementation was obvious enough that it would then generate ideas around around use cases. Because
Not anymore.
I think like if one thinks about STM as a way to handle transactions, it's not very interesting. When it becomes interesting, it's as a way of checking, basically as a synchronization primitive, put it this way, because of the logic around retrying as in an asynchronous fashion. And I can show that. One idea would be, let's do something. Let's create a semaphore. What is a semaphore? Well, a semaphore, we have it in effect itself. We already have one function called effect.make. Actually, we have a semaphore module. And the semaphore.make, we specify a number of permits, like we have one permit, and then we have a function which is called with_permit, where we can run an effect. So like effect dot delay 1000, effect dot log hello world const run. So now I have an effect that is delayed by 1 second, and it prints hello world. Let's say I want to run this effect repeat times 5 const repeated why are the types like this? Do I have to do it this way? I have to do it this way. Yeah, inference. Actually, let me also rewrite this in a slightly nicer way. We said effect dot delay 1000, effect dot no semaphore with permit. This repeats it 5 times, but actually this is not what I want to do, because I want to run this stuff in parallel. So maybe should I use the...
Do we still have an effect.replicate?
Not sure. Replicate, yes. We do have effect.replicate, which gives me an array of times 5. Okay. Let's say effect.all concurrency unbounded. So if I remove the semaphore, and I yield this, what I see, hopefully, effect dot, actually we are in node, run.
And also, as Mike's writing code, if anybody has concrete questions about STM as he's like explaining things, please feel free to write it in the chat, either in YouTube or Twitch, and I'll make sure to relay the questions. Also, a cool thing is that I think that we
We
can
no
run.
longer have TSX.
You can run with Node directly now because we're ESM
Yep.
only.
No, I cannot.
What Node version are you on? 22.
Oh yeah, 22 is too old. Yeah, needs to be at least
Do the-
24. That yeah.
Yeah, you can just do a -- experimental.
I think
Or you can
I
just
have
install-
mix.
You can just install TSX as well if you want to just get this running quickly.
Or I can probably do ban. This also means that we have a broken flake.
I'll have to take a look at it.
So you see, without a permit, I'm running 5 instances of the same thing. It prints 5 times hello world, all at the same time, because I'm waiting a second and then printing everything. Let's reintroduce the semaphore. And what happens now is only 1 per time is allowed execution. If I allow 2 permits, 2 at the same time are running. So a semaphore is a way of controlling concurrency of our program. And it's a really nice structure, but it has one issue. Let's say that I have semaphore 1 and semaphore 2, and I want to take both a permit on semaphore 1 and a permit on semaphore 2. Now, in this case, we would not have any issue because there are really no race conditions. But what happens here is that first I'm gonna take a semaphore out of semaphore 2, and only once I've taken a lock on semaphore 2, I'm taking a lock on semaphore 1, which means if I have any conflicting transactions and one requires, for example, run 2, but it does it in a different order, if I run those 2 concurrently, they would deadlock. Because the first will take semaphore 2 and wait for semaphore 1. The second will take semaphore 1 and wait for semaphore 2.
It also
And
may be
neither
easier
can
to grok
complete.
this if you adjust the number of permits to a single permit.
Yes, probably.
Yeah, now it should be a little bit easier to grok.
I would still have to run like probably run 1, run 2, run 1, run 2, run 1, run 2. I'm not sure if we will deadlock. Hopefully we do. We do not. We do not, because why are we not deadlocking? Why are we not deadlocking? The funny thing is I've done the same example in the past, and I remember not deadlocking and then spending like 10 minutes understanding why I was not deadlocking.
We should like pull up the VOD and like remember what we did, because I remember that as well. I remember I was like trying to simulate a deadlock, and then
Let's see if the clunker is smarter than me. We are for
I can confirm it's smarter than me. So
semaphore example.
there were a few questions in the chat while Mike's typing. One question was, is Deno recommended for effect? I noticed that there's no platform for it. We test against Deno in as much as we can, but it's not like one of the first class platform integrations we have at the moment. There is a work being done. There's work being done on it, sort of. But it's not like a first class integration we're focusing on at the moment. I think that there's multiple reasons for that. I mean, we can get into that maybe over Discord, but it's not a first class integration right now. And then the second question, maybe this one Mike can answer while the clanker's running.
And generally, we do not recommend Deno.
We do not recommend Deno. I have I have strong feelings about Deno that I'm not going to share on a stream. Mostly because it just constantly breaks my CI jobs. There was a second question that is, I think, for Mike. Can STM be used for multi-agent orchestration? If so, what are some of the concrete use cases? I think the
bit of a generic STM question. That you can use whatever you want. Per se doesn't help.
Like, I feel like with STM, it's one of those things that you don't need it until you actually need it, right? Like, and the situations where you actually need something like STM are not as common as like using other synchronization primitives. But like when you have these types of deadlock situations, like if you're facing a deadlock situation, that might be a time where you like think about, could I solve this with STM? But yeah, in my experience, like STM is one of those things that I have reached for maybe a handful of times, and it's not like you only use it when you need it, sort of thing.
Let's see what it did. It created 2 semaphores, okay. It created 2 deferred, fine. Probably better than timeouts. Then it created a worker. Now it is dump your dev logging because we are simply running demo. The dev log situation should be on a process that would complete without log, and the log should be generated by taking for conflicting Yeah, now it dumbified it too much. Let's see.
Have I been like just talking on mute this whole time?
No. You were not muted.
No.
Did you guys hear me talk about the question about TSGO?
Oh, no, yes, yeah. No.
Okay, then I was muted the whole time.
Okay.
Yeah, so I'm just checking our CI job because PN. I know we originally had the effect small CI written to run it with TSGO. But I think that we reverted back to plain TypeScript just to make sure that we were building the same stuff that we were like testing in CI. Because we had it so that like TSGO was being used for like checking types, but regular TypeScript, like JavaScript TypeScript, was being used to actually compile the code for distribution. So we reverted that and made it all go back to just like the plain TypeScript and CI. But we run like ourselves TSGO. Like if you look at the effect small repository, there's a package JSON script for running the TSGO compiler against the repository. So it should work, Ratius. TSGO should be very much compatible with effect small. You shouldn't have any issues swapping over to it. If you do, please open an issue, by the way.
Okay, I think we got a decent example. And fundamentally,
Plague, I'll get to your question after Mike finishes this explanation.
The issue here is that we are fundamentally, we have a body. The final body is dependent on taking two semaphores, taking a lock on two semaphores. And if we do it on reverse order with unfortunate timing, we end up in a situation where the first process to continue waits on a lock which is taken by the second process, and the second process to finish requires a lock that is taken by the first. So we have the classical situation of we can't do anything about it, and it's dead. The issue is that taking a lock is non-transactional, which means we're taking the first, only then we're taking the second. This issue would not be reproducible if we took the two locks within a transaction. So take the first, take the second. If I fail to take the second, it's like nothing happened. I don't block the first. This is very hard to do unless you have something behind the scenes like STM. How do you build a semaphore around STM? Well, it's very easy. You fundamentally say we have a module which is called a transactional semaphore. I'm not going to use it because it kind of defeats the purpose of showing what a semaphore is. Let's actually say make lock. So a lock is a semaphore with a single permit. It's easier. Effect.gen const permits. We create a transactional ref with a simple number. Let's do it in the same way. We're creating a reference that keeps track of the number of permits. Then we have a constant take permit. And here we say const current permits, actually available permits yield txref.get. Let's rename this to permits ref so it's clearer. Now we have a number of available permits, and we say if available permits are greater or equal than the number of permits we want to take, that's good. We can take the permit, which means txref.set available permits minus n on permits ref, and we return. Otherwise, we return effect.retry transaction. If you see at the signature here of this function, we now take a number, and in the result, we have effect.transaction. Because we are reading references, we're doing checks, and we are retrying in case the transaction fails. Here I can also return the number of permits taken to make it easier. Similarly, I can implement a release permits. In this case, there's not much I should do except saying a plus. There's no case in which this can fail, so I don't need to retry in any case here. So now I have two functions that allows me to take a permit and to release a permit, and return. I can just return take permits, release permits. So what happens in this take permit function is, again, we check if we have a number of permits available. If we have enough available, we take them. If not, we keep retrying. This will retry only when the value of permits ref changes, which means we are fundamentally waiting for permits to change, and anytime there's a change, we check again. Are those enough? Yes or no? If no, we keep retrying. If yes, we take them and return positively.
So is this how you prevent like a busy retry loop with STM, sort of?
Yes, because the alternative would be a while loop, and a while loop would block the thread, so it would not allow anything to continue. So
Right.
we would have to retry, for example, on next tick or similar, set a timer and retry every number of milliseconds. Instead, we have a very efficient auto retrying mechanism. The difference between this semaphore and the other semaphore is that now we can take two semaphores at the same time, because if we refactor this to our make semaphore, it will not succeed. But what I can do here is effect.all. Actually, now I have to say effect.commit. effect.transaction, sorry, effect.all, first.take, second.take. And this occurs in a single block. Same on release. I can do effect.transaction, effect.all, second dot first dot release.
You may have to change the types.
Yeah, I do have to change the types.
Or you could just change the return value of the, yeah. Also, somebody in the community very astutely pointed out that a function with a gen return is an anti-pattern, and you should be using effect.fn.
Yes. And that person was not Mattia.
No, it was not my LSP this time.
It was not the LSP, okay.
So Ryan, yes, that is correct. We do recommend fn instead of a function returning gen, but this is just an example.
What am I doing? Make semaphore requires a commit.
Hey, I told you that. All right, that's good.
I cannot
That means
remember my APIs. I need
that means we're doing better with the clankers. We've been doing a lot of work with 4.0 and the LLMs, so.
So now hopefully this does not deadlock. No, it still deadlocks because the example is made for it to deadlock. The example should be something that deadlocks only when
Blank, regarding your question, so Blank asks, when we talk about semaphore, is it like a mechanism to control access to a shared resource in a concurrent system or the operating system semaphore? Technically, I would argue that they're both similar in definition because the OS semaphore does exactly that. But in the case of what we're speaking about here, this is like a software level semaphore, not the operating system, like primitives that allow you to do the same thing. There's also a question, this is unrelated to STM, but what is the pattern about in the effect code base for interfaces with a type ID in it? It's just to restrict assignability, like structural assignability to types that have been sort of like branded with that type ID. It's to prevent you passing something that looks like an option into a function that expects an option, for example, because we may have modified the prototype of option to do different things. It's basically a way for us to restrict structural assignability to things that have that type ID on it without using branding directly. So we can preserve like structural assignability. There's another question somewhere. This is off the current topic, but what was the reasoning for completely removing the either module, renaming it to result when the exit exists to serve as a result type? Well, exit and result are not the same, just like either and exit are not the same. We just renamed either to result because we felt it better communicated the semantics of like most of the use cases of either. Exit is like both are types that can represent either success or failure. But an exit, when it represents failure, represents the cause of failure. It has a cause of all the failures in the error channel. So it's a lot more detailed, and it's meant to represent the exit of effect programs. Result is not powerful enough to represent that.
And exit could be encoded as a result of either A or cause of E. So it could be an alias on top of result. It's not mostly for performance reasons, because exit is the only module which is actually a subtype of effect, so that effect.succeed with a value is basically already an exit of that value, and we avoid boxing on some hot paths.
Mike Clanker has been on a roll with the V4 documentation just by cloning the repository into my code base. It's amazing how much better the outputs are with that context. Glad to hear it. Hopefully we can keep making it better and better as we sort of figure out what works and what doesn't. Auto retrying mechanism at home, set interval. Yeah, try doing that on Cloudflare's runtime and see how far it gets you. Can you run a complex effect service on AWS Lambda now? You should have always been able to run effect on Lambda. If you're encountering problems running effect anywhere, please open an issue. But effect, theoretically, you should be able to run anywhere the JavaScript can run. Big fan of Michael's work, by the way. Not Mattia or Max, just Michael.
Fair enough. Fair enough.
This is actually the Michael fanboy stream. It's not Effect Office Hours. It's just the Mike fanboys stream. Oh God. What are your thoughts on GPT 5.4, and is it the best model for Effect v4?
It's clearly having problems now.
I like 5.4 generally speaking. I think it's a good model. I think in my experience, it requires a lot more being much more careful with the context than Claude, for example. Like I have to be much more cautious about what ends up in context versus what doesn't. And I find myself creating fresh sessions more frequently with code like GPT 5.4. It was the same with Codex, to be honest with you, but like I find myself like creating new sessions more frequently. Yeah, I think oh, sorry, go ahead, Mattia.
I was saying that also that I also think that compared to, for example, 5.3, I am under the impression that it tries to better understand the intent of the action you ask to it, rather than with 5.3 it was more like if you gave a precise instruction and that collides with the intent you generally described, 5.3 would struggle a lot, whereas 5.4 is more compliant with that.
Yeah.
And I feel like also 5.4 is much more Opus-like in some scenarios.
I agree with that.
It does stuff more autonomously. It also sort of inherited the issue of Opus, that sometimes it tries to do patchwork. So it kind of picks I think instead of resolving the root cause, it keeps trying to
Find shortcuts.
make it work with 100 different patches here and there. So I feel like you need it. It's probably a better model than 5.3. I'm getting used to it, but I would like something in between 5.3 and 5.4. She's like,
I don't know what your experience, Mike, with Pro is, 5.4 Pro, but in my experience, like I just tried it like for a few things and I found it to be unusable.
unusable.
Yeah, like the Pro version of 5.4. Like it takes all of the things about regular 5.4 and like just makes it it's like enhanced, like all of the problems you just described.
Yeah, like now it's should be.
While Mike is arguing with 5.4. Yes, we are using Effect v4 right now, Morgan. Mike is demoing some stuff about semaphores, which we can review when he gets to a program state that he's happy with.
I think that
sorry,
I think
ahead,
Mike
Mattia.
that Mike should try to change the model to Timmy, and probably that would work better.
Yeah, let's get the
I'm
Timmy
about to
model
switch
in
to
here.
Opus because I know Opus can do it.
There was a question in Twitch, another off-topic question, but what happened to effect.iterate in v4? I found it a very beautiful primitive for doing infinite looping while keeping track of state, long polling.
Use a while.
I think that you can just use a while or like a regular looping in a generator. Effect.while is like an optimized version of a while loop for effect that you could use as well. But like my suggestion would be to just use a normal like looping constructs in a generator wooter. Because yeah, we're trying to keep the API very lean, avoid like tons of different ways to do things. And regular looping constructs are basically equivalent to effect.iterate. Wow, there are a lot of questions. Hang on. I have seen effect code where semaphore is used for managing concurrent requests. How many requests can be in flight at the same time? Is that a valid use case for semaphore? Yeah, it's not so much like use cases for semaphore are when you want to control concurrency at all. So like if you have an effect program that's running and you want to have very fine-grained control over what runs where in a like highly concurrent like service or something like that, semaphore can be a really nice primitive for that because you can like control how many, like you have access to like the ability to control permits. If you want an open close semantic though, like latch, the latch module in v4, which was called effect.latch in v3, or effect.makeLatch, something like that, is also really nice for that purpose if you just need like open close like gated semantics. But yeah, semaphore is really nice for when you want to have very fine-grained control over concurrency, like when you need to manually control concurrency. But in many cases, the higher order effect combinators that allow you to specify concurrency are enough. Somebody mentioned that they would, FIWS mentions that they would like another LSP live stream, Mattia.
Oh, maybe soon enough we would have something new to show. Wink, wink.
Blank you. Oh, sorry. Go ahead, Mattia. What'd you say?
I was just saying that probably soon enough we will have something new to show with the LSP. Wink, wink.
Wink, wink, hint, hint.
Wink, wink.
Max just needs to get his.
Check the organization for a newly published repository.
Exactly.
Max just needs to get his ass in gear and like set up the infrastructure.
Oh no,
stuff.
that wasn't my intention. Sorry.
No, that I know. I'm just kidding.
I have the example.
Mike has the example. Let's do one more question and then we'll do the example. Where was it? Mostly the actor pattern is where I've seen the concept of effect.cluster used. Yes, that is correct. I'm moving from TRPC to effect for stronger guarantees and better open API support. It may not be standard, but I love to define APIs once and glad to hear it, Gonzalo. When effect router coming? Also soon, hopefully. Oh, okay. Last question, and then we'll go through the example. Karkanov asks, Effect Days 2026, any plans? Wait, I can hear Mirella in the background. Just like, oh, God.
Yes, there are some plans. We don't yet know the details. The reality is we had to do some stuff before. We got to organize the Effect Days conference, and I didn't give authorization to proceed with the organization before we unlocked our ability to actually do the conference. Now we are good. So now I've given authorization to begin organization, but we don't yet know the timing of it, because we're trying to still have, like, we don't want to organize a conference and say it's next month without giving proper advance notice and so on and so forth. So we're trying to sort of schedule it properly, but it's gonna happen. So that's the good news. And
Yay!
another soon.
Soon, TM. That's going to be
Soon.
our trademark
Soon, TM.
response to all these questions. Soon, trademark.
Effect dot soon.
Effect
soon.
out eventually. All right. Let's pause on questions and we can go through your example.
The example was indeed fairly easy. I just needed to tell GPT that it should be 10 lines, or otherwise I will fire the model. And it did it in 10 lines. So the trick with the bad example is that I have basically a computation that takes two locks, AB, and then I have it BA, so that does it exactly in the opposite order, and I run them in parallel, which sounded very much like what I was trying to show at the very beginning, and it didn't deadlock. The thing is, when time is involved, it's hard to make things conflict, which is usually why you don't see the bugs locally when you have one user that is hitting your API endpoint, which is yourself, but things starts to fail badly once you deploy and you have more users doing the same stuff, because concurrency bugs end up materializing much more frequently, and race conditions starts to appear. So now I have this bad example which will never complete, because for BA to complete, AB has to finish, and for AB to finish, BA has to complete. Then I have a good example which does exactly the same thing, but it does it with transactional semaphores and acquires AB and BA transactionally. So if B fails to acquire, it's going to retry and not lock A. And we can see from running it that running the good example completes, and instead running the bad example ends up firing a timeout. That's a contrived example about STM, but the key unlock is this idea of being able to retry transactions up until your conditions are met. And you can do much more interesting stuff, which is like, we have various transactional modules. They all start with TX. There's a TX chunk, there's a TX deferred, there's a TX hash map, hash set, there's a priority queue, there's a pub sub, there's a queue, there's a reentrant lock, subscription ref, and we'll add more in the future. But with these, you can do stuff like push to a queue and publish a message to a pub sub, or pull pull objects from a queue only if there are more than 5, wait for conditions on the number of elements inside a queue before you do something else. You can architect these more complex condition-dependent processes that would otherwise be very complex to organize. And
I
I've
think that was
shown,
the I think that was the exact example we used, if I remember, like going back to the stream we did a while back. It was the queue example. We switched from like the semaphore business, and we just decided to use the queue example because it was a lot easier to like reason about.
I think the example that I was trying to architect last time was the idea of taking from multiple queues. Let's say you have like 5 queues and you have one job that should take an element from either of those 5 queues. Doing that with normal queues would be very complex because you have no way of waiting for the condition when there is an element in the queue without taking it. And once you took it, you took it. Let's say, for example, you have a queue of tier 1 requests and a queue of tier 2 requests, and you should give priority to one queue versus the other. It's extremely complex to achieve those without transactional queues. With transactional queues, instead, it's very easy because you can have a condition check and you can have the takes as part of the same transaction, which means if the conditions are not met, you're not changing anything. If the conditions are met, you take the elements without without breaking any other worker which is taking from the same queues. Like doing this kind of synchronizations is weirdly complex, and you can see the difference between, like, I've shown the how to make a semaphore locally before, but if we see the transactional semaphore that we have in the library, it's quite literally the same thing. It creates a permits ref and then it makes the semaphore, which is just an object with a permits and capacity. And taking a permit, so acquire takes one permit, is exactly the same code that I wrote before. It's like if I don't have an available permit, I keep retrying. So I've shown exactly the same code that we have in the library, while instead I can show the implementation of a semaphore and you can see the stuff like taking. This is much more complex. Even for a simple thing like a semaphore, because we have to, keep track of waiters, so people that wants to take a permit when the permit is not yet available. We have to synchronize things properly. Like, this code is much more complex compared to just basically this. Like, this is what you would like to write versus the other. The reason we also have a non-transactional semaphore is because transactionality adds a cost. So obviously creating the journal, the whole infrastructure around retrying on the journal, and so on and so forth is non-trivial, and it adds a little bit of cost. And for very high performance hotspots, like we use semaphores in weird places inside core, it would be not ideal to pay that cost all the time when we have a low level alternative. But if we erase perf as an argument, there is no point in the library having structures like a queue, like a normal reference, we could make everything transactional, and it would be easier to express some of the concurrency problems that we have internally. So from a user perspective, it's not too often the case where you need a transactional implementation, but many times when you end up, like for example, a friend of ours, Johannes, has a lot of concurrent stuff in his own UI work, and it's very frequent that he has to do stuff like taking an element from different queues and stuff like that, and for this STM is perfect. I apologize that the example was not ready to go, but the reality is generating deadlocks and race conditions is hard, and these kinds of prove it. It takes a while to get to code that doesn't work reliably.
No, I mean, I think this was great. It's also more fun to try. In my opinion, watch the process instead of coming with like a full example. And in this case, the process just being you fighting with Jippity.
I thought you were about to say it's so fun to see you fail at writing
that
a piece
too.
of code.
I try to be nice and not say those things, but in my mind,
Yeah, I've heard this from your mind.
That is what's going through my mind. Just trying to reset, because everybody in chat's trying to inflate the ego, and I'm just trying to like
deflate. Okay, makes sense.
It was interesting to see you try to get to the actual situation, to the actual error that the module tries to solve. Yeah.
And well, I get the idea is much broader. It's about transactions in general, but I find it that often we get a question of the type, why is STM necessary in JavaScript that's single-threaded? And the question makes sense because in other languages, STM is used primarily to avoid race conditions and build concurrent data structures that are lock-free. And they use optimistic retries. And initially, I was under the same impression, which is why in the first version of Effect, I did not port STM over. But later I realized that big part of STM was waiting on asynchronous conditions. And these make sense in JavaScript because in JavaScript we have async. We can have concurrent processes. We don't have parallel processes, but we still have concurrent processes. So for many scenarios like the ones we described, STM is the way to go.
If anybody has any questions on the STM stuff we just went through, please drop them in chat. I'll try to answer some of the other questions that came through while Mike was working. Somebody asked, is Effect Days 2026 going to be in the US? Probably not. Definitely not.
No.
The US is just too expensive to have a conference in. Let's just like be real. It's just like ridiculously expensive to host a conference here.
I mean, I'm not gonna deny that we are thinking about a US edition, but I feel like it's probably a next year thing. We are evaluating if to co-host the conference with other friends, other friendly companies that we collaborate with. And the thing is, I feel like both are, I would like to have a US conference and a European conference and not move the European to US, or like not do either of the two, because I feel like especially for a lot of people to travel, they might prefer US or Europe. So
Right.
it wouldn't quite make sense to do just a US edition but not the European edition. But Mirella is gonna kill us if we make
if
her
your
organize
company
2 conferences at this point in time.
if your company wants to sponsor Effect Days 2026 in the US, just let us know. Mirel is happy to do a second conference. It's fine.
Yes, exactly. We need sponsors.
But seriously, if you want to sponsor Effect Days, let us know. What else? Question for Michael. You said that Effect is going to be a full stack framework. Can you expand on this point a bit?
No.
when Mike immediately regrets his tweets.
Well, that tweet has a basis. And the reality is I've been pushing the boundaries on basically my thesis here is that we will not write a lot of code by hand in the near future. And I'm trying to optimize for the code that we generate to be production grade. And I think we are at the point where with Effect we can reliably generate production grade code for the backend, and we can reliably generate production grade code in the front end when we use like Effect Atom in a single page application without routing involved, without server-side rendering, and so on and so forth. Once we start plugging in other frameworks, and here like I don't want to badmouth a framework in specific. It's kind of all the frameworks share the same problem. Things starts to go wrong, and the primary issue is like the reason why I built Effect in the first place is that developers are kind of lazy and they need guardrails to build code that works. I need guardrails by myself, so this is not meant as a cheap shot for other developers. I'm exactly in the same category. We get lazy if there's a way we can cheat, we cheat, and problem starts to appear when we deploy code to production. And AIs are even dumber than us developers. They can be very effective, but they are dumb. And when they can take shortcuts, they will take shortcuts. And frameworks are currently built under the assumption that there are some unwritten rules that are not specified by the type system that the developer should follow for the code to work well. And everything is perfect once you follow those rules. And the agents can follow those rules. If you prompt them in a very precise way, they will follow those rules up until the point where they forget the prompt and they start to produce slop. And it's very hard to prevent slop when your full system is based on stuff like React server components, server functions, and so on and so forth that hide the fact that the network boundary exists. Generally speaking, in computer science, there are papers that go back to the 90s that clearly state that the idea of pretending that the network doesn't exist is a very bad idea. And in the software industry, we like to rediscover the same things over and over again every few years, because we still have to keep our job. Otherwise, in the 80s, all computer science was done. Like now, we build Effect cluster like an innovative solution. Beam in Erlang exists from the late 80s, and there would be no point of building Effect cluster if the world decided that Erlang was the language of choice and we didn't invent JavaScript. So the fact that we want to reinvent and rediscover the same problems is a funny exercise, but in this case, the underlying problem is faking the fact that the network does not exist. and pretending that the compiler will figure it out without proper hinting and stuff like that. So what we want to do with Effect, the full stack framework, is provide a framework that is designed with guardrails in mind for agents to produce full stack code that works well out of the box and that does not have the same problems that other frameworks currently have. And I see a comment where Effect Cluster is the sleeping giant. Yes, it is, and you can expect for a full stack framework around Effect to have all bells and whistles necessary for it to, for example, to do long-running workflows, HTTP APIs, automatic client derivation, and so on and so forth. So it's kind of our take on building production-grade software that can be automatically generated. And that tweet was prompted by some other tweets that were denying the importance of Effect. I woke up on the wrong side of the bed and I made the tweet. It's not an announcement that the full stack framework will come out, but we are working on it. And Sebastian is, for example, already working on Effect Router, which is an essential piece of the Effect framework. So expect something to appear over the next few months. No specific deadline, and the full purpose is for agents to be able to generate full code bases, front end, back end, everything in between, with a result that is performant, observable, and what we call production grade.
Yep. Somebody at FIWS had asked, this is again like just I'm jumping around to questions that I see, but I thought the core of Effect did not use generators internally. Did this change in V4? No, it did not change. We do use generators internally, even in V3. I think when V3 first came out, we were not using many generators, and that's why a lot of the V3 code doesn't use generators internally. But for like larger scope stuff in V3, we started using generators internally when we were able to optimize. Mike can probably talk about like the optimizations we did for Gen that like made it possible, but no, the core of Effect definitely does use generators internally.
The thing here is that for a long time, we thought generators were slow. What we didn't realize is that the overhead was the creation of the generator object. When we use effect.fn, the generator is created only once, and it's only used later. And that's way more performant than, like, if you do const arrow function returning effect.gen, anytime you invoke the arrow function, it's going to create a new generator object, and that's what makes it slow. With effect.fn, that overhead is gone, and it's much faster than the alternative. So we are using the generators in the core. We are not using generators yet in the runtime of Effect, so in the Fiber context itself. I feel like there we need the absolute best performance we can get, but many times for internal combinators, using effect.fn untraced is much more performant than what we could do without, because one, they get optimized by the just-in-time compiler very decently, and basically the fact that we have a mutable scope allows us to do some hacking that you should definitely not do in application level, but that would be very complex to do with nested flat maps and stuff like that. So we would end up generating more overhead with without the usage of a generator. So that's the reason we changed our policy.
Follow up. Oh, interesting. Does effect.fn need and have a name for that optimization? I guess not. I'm just confirming. I don't think there's a name for that optimization. I think it's just avoiding reallocation of the generator every time we call a function. So instead of returning a generator object from a function, we create the generator up front. Oh,
And
the
probably
architecture.
that question, I think the user is asking
If the name
about
parameter, yeah.
the name parameter in fn, which is completely unrelated. So the performance heavy optimized version of fn, it's called fn untraced, which removes any tracing logic from it. So that's what you should use for hotspots where performance is incredibly important. And here by performance, I mean synchronous performance. Like you're not gonna optimize an IO bound application by just swapping from FN to FN untraced. Effect FN adds stack traces, which means if something blows up inside an effect.fn, you're gonna see the stack trace of where that blowed up. The name parameter on effect.fn enables you to also generate a telemetry span out of it. So technically, in user code, what I would do is I would always use effect.fn with a name for pretty much all the business logic and get telemetry out of the box. That's what I would do. But it does add a little bit of cost because obviously we have to capture the stack trace, we have to generate a telemetry span, and so on and so forth. But realistically, anytime you do any async work inside the function, the cost is absorbed by the operation itself, so it doesn't really matter.
Maybe we'll take one more question and then we'll kind of close up office hours since we've already been going for an hour and a half. The last question was from RJ. Now is perhaps not the time. I'm happy to wait, but I'm very curious to hear the effect folks take on the Elm architecture for front-end state management, maybe as the full stack effect story matures. And also, sorry, I did not know what T stood for. I only have space in my head for medical acronyms. All other acronyms do not exist. Do I have an opinion on this? I don't think I have an opinion on this. I'm going to be honest. I think that for the full stack effect framework thing, we don't really have a concrete idea of what it looks like yet. I think, maybe like Mike said, yeah, maybe I don't. Maybe Mike knows exactly what it's going to look like, and we're all just living in his world. I think that the effect router that is being iterated on currently is the first step in that direction. But personally, I don't have an idea of like what full stack, like what effect on the front end specifically looks like. I think that effect Atom is already a great experience for using effect on the front end. Like from my point of view, I've really been enjoying using Atom on the new version of the effect website that we're working on. But I don't know like what the rest of it looks like personally yet. Like, but I think that router and Atom will definitely be like big pieces. So that's my opinion. I don't have thoughts on the Elm architecture. I'm sorry. Sorry, RJ.
I have some thoughts, and I find it not very composable and not very self-contained. it's good in theory to have a separation of concerns between state, transitions, and UI. In practice, it never went well when I used it. And it's kind of like event sourcing in the backend. It's something that makes a lot of sense in principle, but once you start using it, it kind of fails. The That might be a key issue on my side, but I feel like for the full stack framework, we don't want to be this prescriptive. We want to be more general and giving you the primitives so that if you want to do the Elm architecture, you can. Effect Atom, as Maxwell said, it's already a very good primitive for state management in the front end, and we will lean more heavily on it. The missing pieces that we want to connect are the server pieces and the wiring between a server and a front end. And maybe it's one of the things where AI kind of becomes a design changer again, because I always felt the Elm architecture was very verbose and very hard to maintain. But maybe LLMs have a better, uh, have are better with it because of the separation between state and so on and so forth. So maybe there's gonna be sprinkles of the Elm architecture here and there, or maybe not, and it's all left to the
Sprinkles.
user. Sprinkles.
Sprinkles.
I don't know English anymore. The
No, I
fact that
like
I've been
sprinkles.
interacting mostly with LLMs that don't care about grammar, and I can just yell at them.
It's just
Much
degraded
easier.
Mike's English.
Yes.
Cool. Mattia, I don't know if you have thoughts as well.
I mean, Mike already captured like the 70% of the thought I have about the Elm architecture. Again, it's a great idea on paper. It's so like almost impossible to write production scale software adopting that idea 100% of your application, but because as Mike mentioned, at some point it becomes so verbose that you lose yourself trying to understand what's going on in the code. I've always been like a fan of the reactive approach. I mean, I've always had fun with MobX, for example, back in the days, because that's the approach I believe in. It's also like one thing that I really love with the reactive approach is that you can have a primitive that takes in account like for things that are derived in an asynchronous way, which is in the Elm architecture. Instead, you have more like as they're defined as a series of snapshots of instance in time, which is like more difficult to write and reason about, whereas your mind is usually like more easy to think about. This is reactive, this changes and attempts to run some asynchronous computation when their sources changes. So it's more like a user experience take, the one I have. But yeah, overall I agree that it could change with the LLM. It gives like the LLM probably something more rather than the reactive approach, but let's see. I mean, we don't have data that confirms that yet.
And
Cool.
RJ is saying that he wrote Elm in production for 4 years, so he had a very different experience. I would ask just the Elm architecture or Elm the language, because I can see how within a constrained environment like the Elm language, it could actually scale much better, because the kind of the tooling is designed around that. When I meant I never had a good experiences when using it sort of shoehorned inside React, without a lot of dedicated tooling. Yes, the language, RJ. Thank you. So
Okay,
yeah,
with the
I believe with the language it's a different experience, which is also why I'm saying maybe LLMs change the logic here, because if we had the right tooling and the right framework primitives, it could actually make the difference.
Cool. Well, if there's no other questions, we're gonna probably stop here. But thank you all very much for joining Effect Office Hours this week. If we didn't get to your questions or you have other things you want to ask, please feel free to post in Discord, and I'm sure we'll get to those. But yeah, until next week, folks. Hope you all enjoyed it, and we will see you next time. Cheers, everyone.
Cheers.
Cheers, everyone.